So being able to identify the amount of significant figures in a number is, of course, not the only skill we need to have when it comes to significant figures. Another important thing is understanding how to report the correct number of significant figures when we're making measurements. And this is really important for communication between scientists, between healthcare workers, to make sure we're reflecting the precision in which we are making our measurements. Okay, so scientific measurements, as it says here, are reported so that every digit is certain except the last, which is estimated. Okay, so what does that mean? Let's take a look at that. So when you are making measurements, okay, you want to report all the values that are known, and you estimate the last value, and here it says by looking at the meniscus. Okay, so what does that mean? So when you're reporting a measurement, you're going to reflect how accurate, or I'm sorry, excuse me, how precise your tool was in making that measurement. So if we look at the thermometer on the left here, we can see that we have a temperature here. Okay, let's assume that this is in Celsius. And we can see this big hash mark is marking 20, this other big one's marking 30, and we have this other one, which we're going to assume is midway, which would be 25. And then we have these little hash marks along the way, so 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay? And so our measuring tool, in this case the thermometer on the left, is telling us our precision to the ones place, right? We can see this is 20, this is 21, 22, 23, 24, 25, right? And the actual temperature here, we can see, is coming up between this hash mark, oops, here, and this hash mark here, okay? So we can see that's between 23 and 24, okay? And so we have to report this temperature, but we're going to estimate, like we said on the previous slide, we're going to estimate the last digit. So we know it's between 23 and 24. And we might say, like, to me, it looks like it's a little bit closer to 23 than it is to 24. So I might say that this reads at 20, and I might say it's 23.3. Okay? And again, other people might not agree with this. They might say it's 23.2, or no, it's 23.4. And the point is that it's a little bit, it's closer to 23 than it is to 24. Okay, so we're estimating that last digit. Okay, now let's take a look over here on this end at these graduated cylinders. Okay, and on these graduated cylinders, we can see we have two different graduated cylinders. The one here with this green liquid, if we look here, we have a mark at 8 milliliters and another mark at 9 milliliters. And then there's marks in between, right? So this is 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, 8.8, 8.9. And then 9. So this measuring tool, the graduated cylinder, is giving us our first decimal point, right? It's giving us to the 10th place. And whenever we measure something like this in a graduated cylinder where due to the surface tension of the liquid, it kind of curves and creates what's called a meniscus, where you have the U shape of the liquid, you always want to read at the bottom of that meniscus where this dotted line is drawn. Okay, so that's where you are going to make your measurement from. And we can see that the bottom of that meniscus of the green liquid falls between the 8.4 line and the 8.5 line. And again, we always report one digit more than what our measuring tool provides for us. So since this is providing to the 10th place, when we report this value, we should be estimating to the 100th place. So we should have two decimal places. And again, this seems like it's falling, and I would actually disagree with this image. I think it looks like it's closer to 8.5 than 8.45. But again, that's the point of estimating that last digit, is to give your audience, whoever that may be, an idea. Was it closer to 8.4 or was it closer to 8.5? We understand it's an estimation. Okay. Now compare that to the graduated cylinder on the right with the purple liquid. Notice you have a hash mark here at 55 and another one here at 56. We don't have those little hash marks in between to mark off the tenths place, okay? That one digit. This is a less precise graduated tool. Okay, sorry, a less precise graduated cylinder. So a less precise measuring tool. So therefore, we know, again, the bottom of the meniscus is somewhere between 55 and 56, and we, as the person reading and making the measurement, have to estimate that decimal place. In this case, 55.6. Again, it's in between 55 and 56. It's a little closer to 56 than it is to 55. Okay, so again, it's one digit more than the tool you are using to make your measurements. But of course, these are analog tools, right? If we have something like a digital scale that you would use in a lab or in your virtual labs online, it might give you several decimal places. Like this digital scale would give you 1, 2, 3, 4 decimal places, and whenever you're reading, making a digital reading, you record the whole value. Okay, you don't need to estimate. The hardest part about this is when you're actually doing it in lab is sometimes that last decimal is jumping around, and you as the scientist, or the person making that measurement, do the best you can and write one of those numbers down. So now we'll do some practicing on making or reporting the correct number of significant figures while we are making measurements.